Alright, so this time we're doing problem 59 from chapter 4. And this question has a bit of background information that we need to know in order to solve the question. The background information is dancers experience large forces associated with the jumps they make. For an example, when a dancer lands after a vertical jump, the force exerted on the head by the neck must exceed the head's weight by enough to cause the head to slow down and come to rest. The head is about 9.4% of a typical person's mass. Video analysis of a 65 kilogram dancer landing after a vertical jump shows that the head decelerates from 4 meters per second to rest in the time of 0.2 seconds. Question 59 asks, while the dancer is in the air and holding a fixed pose, what is the magnitude of the force her neck exerts on her head? Option A, 0 newtons. B, 60 newtons. C, 120 newtons. Or D, 180 newtons. We got to pick which of those options is the right option. So in order to do that, we need to use some of the information that we're given. We know that the dancer's initial velocity is going to be 0. Velocity final is going to be equal to 4.0 meters per second. The time that it takes to change is 0.2 seconds. The mass of the dancer is equal to 65 kilograms. And that the weight of the head is 9.4% of the total mass. So, in order to find the force, we need to use the equation that the force is equal to the mass times the acceleration. But we don't have an acceleration, so we need to find that first. And to do that, we're going to use the equation that the acceleration is equal to the velocity final minus velocity initial divided by the time, which when we plug our values in is 4.0 minus 0 divided by 0.2 seconds, which then gives us an acceleration of 20 meters per second squared. So we have an acceleration. We then need to find the mass. And so we know that the mass of the head is going to be equal to the total mass of the body of the dancer times the percentage of the weight that the head is equal to. So that's going to be 9.4 divided by 100 times 65 kilograms, which gives us a mass of 6.11 kilograms for the mass of the head. Because the force on the head from the neck and the force on the neck from the head are going to be equal, otherwise your head or your neck would detach from the other one, we can use the mass of the head to find the force that the neck is exerting on it. Because that force is coming from the neck, but it's moving this mass, the mass of the head, with this acceleration. So we then just plug it in, so we know that the force is going to be equal to the mass, 6.11, times our acceleration. But this force over here is not just the force of the head times the neck, it's also going to be the weight of the head, so the mass of the head, I should probably leave these as letters, times gravity. That's the total force that's going to be acting right there where the neck and the head join. So from this, we can find that the force is going to be equal to the mass times the acceleration times the mass times gravity. We can then pull the mass out. And we can then plug in the values. Obviously, gravity is the gravity on Earth. So that then becomes 6.11 times 20. This should be a plus because we subtracted it. Plus 9.81. And when you solve for that, you get a force of 182 newtons, but rounding to but we had to choose from one of these four options. So with significant figures of 2, we can see that D is the right answer.